Okay, the past professor is on again. Return with us now to those days of yesteryear, etc., etc., etc. All right, so chapter 1 is the introductory chapter, and we will talk about these sections. I'm praying they match with the sections in the 5th edition book. All right, so a production system is a collection of people, equipment, and procedures organized to accomplish the manufacturing operations of a company. Okay? We have two categories within that. One is facilities, the factory and equipment in the facility and the way the facility is organized. The other is manufacturing support systems, the procedures used by a company to manage production and to solve technical and logistic problems in ordering materials, moving work through the factory, and ensuring that products meet quality standards. Okay, so that seems pretty straightforward. So here's kind of a org chart illustrating that we have the division between the facilities and manufacturing support systems. All right, so our production system facilities. Again, our facilities include our factory, our production machines, tooling, material handling equipment, inspection equipment, computer systems that control manufacturing operations. Okay, so I hate it when I forget to get the candy out before the class. The plant layout is the way that things are actually arranged in the factory. Of course, you'll learn more about that in facility layout and design. The manufacturing systems are logical groupings of the equipment and workers in the factory, which can be in a production line. I would include in a production line also work cells or shops and standalone workstations and workers. Although a standalone workstation does not have to have a worker, as we will see as we go through this course. Ugh. Manufacturing systems. We have three categories, and it depends on how much humans are involved, how we categorize them. A manual work system has a worker performing one or more tasks without powered tools, but sometimes using hand tools. I would say that hand tools also include small powered tools, drills, electric or pneumatic ratchets, etc. Worker machine system, where a worker is operating powered equipment, Man, you're putting down a lot of notes.
Oh. Sorry.
That's okay, as many as you need, man. And an automated system is a process where the machine does the work without direct participation of a human. Okay, I'll bet you this is Tara. Hello. I know the computer here in 325 won't connect to the internet. Okay, so I'll post the video of the class tomorrow morning. Yeah. Yeah, sorry, that's all I can do. All right. Right. No, I'll get IT to come in and fix this, but I can't do it right this minute. All right, have fun. Can I call them or can I call them? All right, so we have the automated system where you don't have direct participation of a human. The system might give a signal if it gets jammed or has some kind of a problem that it can't fix itself. But in general, you just turn the automated system on and it goes wild on its own. All right, so this is a little illustration of each of those systems. In system A, the worker has hand tools, they're doing the process. System B, you have a powered machine and a worker doing the process. And in C, as you see, we have the periodic worker attention. As I said, the machine gets jammed, it runs out of some supply that's important, but mostly the automated machine does all the work. All right, so inside our manufacturing support systems, we have the business functions, of course, are often not considered by the engineering and technical staff, but they perform important functions. You've got the sales and marketing. If we don't sell any, we're not going to be making any. Order entry, cost accounting, customer billing, all important things to keep the wheels turning in the factory. Product design is important. Obviously, we have to have products to sell. So that includes research and development, design engineering, and a prototype shop, which may or may not be part of the design engineering function. Depending on the size of the company, that may all be one thing, or it may be two things. Manufacturing planning. Obviously, we have to have process planning. How do we do the processes to make the products? Production planning, what gets made before what, and how many of each one do we make? MRP. MRP, depending on who you listen to, is material resource planning, or oh damn it, what's the other one they were trying to make all popular? I've forgotten the other one. And capacity planning. There's obviously a limit to how much we can make or do at any time. So it becomes important that ties in with our process planning and our production planning on how many we can make of what. And that brings in also the famous operations research. What is the mixture of products that is going to be the most profitable for us? Then we have manufacturing control. That includes shop floor control, which is pretty obvious. You have supervisors and shop floor engineers. Inventory control, how much of what are we keeping in our storage so we can keep our production going, and quality control. And notice they don't mention quality assurance in there anywhere, which should be under manufacturing planning. All right, so a flow diagram of how we do our processing. We get an order to produce something. That has to go through all the business functions. If it's something that we haven't made before, it's going to end up going through the product design. Then into manufacturing planning, manufacturing control actually goes back and forth with the factory operations, right? So we're going to have materials, whether they're raw materials, whether they have been manufactured by somebody else, and we buy them as parts. And finally, the product goes to the customer. Often we call this kind of work computer integrated manufacturing now. And we look at it from the aspect of the division that we talked about before between facilities and manufacturing support systems. We say, how much automation do we want in our manufacturing system? Obviously, that implies that computerization goes into that. And actually, there's computerization in every one of our functions up and down the line. Right? The days when there was only a computer at corporate headquarters and nobody else had a computer, obviously are long gone. All right, so when we talk about automated manufacturing systems, what are we looking at? Automated machine tools. For many, many years, we've had automated screw machines. In fact, that's quite an old technology now, where you just feed in steel rods or equivalent material, and nuts, bolts, whatever comes out the other end. Transfer lines. How do we get parts, products from one place to another? There are some automated assembly systems where you actually have a machine that does the assembly of parts, partially to build the product or completely. Usually, that's done by some kind of industrial robots. For example, a good example of...
Assembly line for car making?
I'm sorry?
An assembly line for car making?
Well, exactly. If you look at an assembly line for cars, the body is welded together totally by robots without any humans being there. The more we can get humans out of the welding process, the safer a process is going to be. When I toured the Kenworth plant up in Chillicothe, Ohio, I was blown away because the big gas tanks for the Kenworth trucks were totally made by a robot. It would pick up a big empty cylinder, it would weld the caps on both ends, and then it would weld the filler neck on. And this is all done in a booth where you can watch it being done through the window, because the glass, of course, stops the bad rays that would burn your retinas, right? But the machine was working all on its own, no problems at all. Very often now we have automated material handling and storage systems to help integrate the manufacturing operations. So we have all kinds of, we also have automatic inspection systems now. A lot of times inspection is still done by hand in most manufacturing facilities. A lot of times that's because they have this superstitious thing, people can see things, machines will miss, or, okay, whatever, man. But you can have automatic inspection systems as well. All right, so if we do have automated manufacturing systems, and that's not to imply they don't exist in the universe, of course. Basically, we have three types. We have fixed automation, programmable automation, and flexible automation. All right, so in fixed automation, it's the processing is done, the operations are fixed by how the equipment is set up. So usually we do this because we have high production quantities and we're just going to crank out the same thing day after day, and we're not going to want to change that or fool with that, right? So it may be a thing of you have a work cell that's entirely automated, where one machine does its part, hands it off to the next machine, and it goes around that way. This can be really expensive depending on how much customization has to be built into the equipment. Again, we only want to do that if we have a high production rate. If we want one a day, probably we don't want that, unless it's something very difficult and dangerous to do. If we're going to make 10,000 a day, we might really want to go into a fixed automation situation. The problem becomes if we have to do a mix of products, that can be a big problem because it's not very accommodating to changing production in between. All right, so programmable automation means that our system can change the sequence of operations so that we can do different product configurations. This is one of the reasons that lean guys kind of like having people working work cells, right? Because if we have a work cell to make alternators for cars, and we're going to have a wide variety of alternators, and they're not all going to have to use the same machines in the same sequence, that's very easy to accommodate with people, not necessarily so much with machines. All right, so again, we have high investment, even for our general purpose equipment. We have a lower production rate, but we have flexibility so that if we have variations in production or changes in the way the products are made, we can make that relatively easily. This is, here they're saying it's the most suitable for batch production. I see this as very useful for a kind of mixed model production as well. All right, so our physical setup and our part program has to be changed between jobs. I would argue that our machines are so much better now that we could probably program the machines to be able to do a mixed model type production where humans would only have to interfere if there was some kind of a problem. Is this a particularly dirty keyboard over there?
No, just being careful.
Carry on. All right, flexible automation. They're thinking of this in terms of being an extension of the programmable automation. So that the machines are able to change from one job to the next and do that kind of mixed model production. Again, you have a high investment partly because automated machines tend to be expensive, partly because part of it may have to be custom engineered. We're looking at a continuous production situation in a mixed model type production. They're putting it at a medium production rate. I would say it kind of depends on how do we define medium, high, and low. And machines at this level, you could probably put in the today's mixed model production as some kind of a program to bring it. Man, I'm running out of breath here. I'm getting a mask. You can see here what they think is going to be typical production type numbers available with each of these. Right, so the product variety, the flexible automation, and the fixed automation. Now, more and more we move towards computerized manufacturing support systems. So when we do that, we reduce manual and clerical effort in product design, manufacturing planning and control, and the business functions. And this is very possible. When I used to teach inventory control, I would show the class how to set up an MRP type system that all you had to do was put in the desired quantities, and it would explode back through the system to break out how many parts and how much of what had to be done. And of course, that was just using Excel. That wasn't, high-level programming by any means. So we're putting together that computer-aided design and computer-aided manufacturing in this. So our computer-integrated manufacturing actually includes both of those. So this is pretty complicated just to make that point. All right, so what are some reasons that we might want to automate? Well, part of it would be to increase labor productivity. One of the reasons that America and Japan have the highest productivity per worker is that we have high levels of automation. For example, down in Mexico, you need to move a crate. You might get 10 guys and say, all right, everybody lift on 3. Or they would probably say trace. Whereas in America, you'd have one guy with a forklift going out and picking it up and moving it. So we increase the labor productivity and reduce the labor cost. If we don't need those other 9 guys, we don't have to pay 9 more guys. It can be really good where we have a labor shortage. Trying to think of an example that would work here.
Which one are you on?
I'm on number 3.
Mitigate effects of labor shortages.
Well, sometimes you don't have a labor shortage as much as you have a skilled labor shortage. For example, people that can program CNC machines are in very short supply in America. Obviously, every time they're able to program a machine to do a task automatically, that means that you don't need a machinist, a fully trained machinist to run that machine. You might just need someone who comes around and loads the machine when it's done. Removing routine manual and clerical tasks makes a big difference. A friend of mine told me about when he worked at, oh gosh, what was it? It was like the Navy jet engine plant, where they would rebuild jet engines for fighters for the Navy. And he said they had this one holdup where you had to have a clerk come around and write off the serial number of each engine before it could go forward. So they'd jam up there. He said what they did was they replaced it by having a barcode on the engines, and it would just go under a scanner, and that would be a financial transaction right there. Improve worker safety, I'm always in favor of that. Improve product quality. Very often a machine will perform the same way every time, which is something that we want. Reduce the manufacturing lead time. I'm going to say hopefully on that one. As you may remember from Lean class, most waste happens outside the value-adding processes. That's where we should always attack first. But engineers always have the tendency to attack the value-adding activities as the ones where they can save money. Sometimes things can't be done manually. In that case, an automatic machine makes sense. Or it can't be done manually at a reasonable cost. Avoid the high cost of not automating. I'm dubious of that point. All right, so manual labor, are we still going to have a place for it in our production system? Well, of course we are. Even the day when you could just dump raw material that went into the building and products come out the other, you'll still have to have a manager. Manual labor has advantages because, first of all, it's more flexible, right? If I have you cross-trained to do two different things in two different places, that's a much different proposition than I have a machine over here that does this one thing that I can't move over here to do this other thing. And there's a lot of labor in the manufacturing support systems. Overall, automation is going to continue to get bigger and bigger and displace more manual labor. The present estimate is that only 31% of manual labor jobs have to be done in a manual labor paradigm. Okay, so how do we tell when to use manual labor? Well, in some countries there's very low labor rates and it's hard to justify the cost of automated machines. Some tasks we have not figured out how to automate, and in fact they may be so complex that we're really not trying to do that. Things when we have short product life cycles, the product is only going to last a short time before a new and different product is brought in. By the time we get the automatic machine set up, that one's already over. Why not? Some customization will require that human flexibility to be able to do it. We also have ups and downs in demands. There's always going to be variation. We know that variation is the enemy of the industrial engineer, but it's not, almost nothing is going to stay the same demand all the time. You know, if we own a garden products company, there are going to be the demand for lawnmowers is going to tank in the wintertime. But at the same time, the demand for snow blowers is going to go up. And they point out very rightly, if we're making a new product that we haven't thoroughly tested out and we don't know how well it's going to sell, let's not get too deeply into it financially until it proves itself. I mean, where is the iPod now? All right, so in our manufacturing support systems, well, first of all, we've got product designers. They've got to be able to show some creativity on how to make these things. The manufacturing engineers designing the equipment, the tooling, planning the production methods and routing. Equipment maintenance, actually over time that is going away as well. They're already starting to think about and build self-repairing robots, or extra robots that come and fix the robots and do the maintenance. They give them little robot overalls.
And a toolbox.
They come up, what is the problem? Programming and computer operation. The project work that engineers do, plant management. Now, in the fullness of time, it's possible that automation will wipe all of these out. But for a long time yet, those are still going to need to be done. All right, so our automation principles, the USA principle, which doesn't mean that we're standing around chanting, USA, USA. The second one is the 10 strategies for automation and process improvement, and the automation migration strategy. Okay. The USA principle breaks down to understanding the process, simplifying the process, and then automating the process. When we understand the process, we have to do the input-output analysis, values chain analysis, or I would call that value stream analysis, and charting techniques. In other words, all the IE stuff that you've been learning here in school has to go into making that happen. Simplifying the process, obviously we're reducing unnecessary steps and things that need to be done, using our lean principles, our common sense, and automating the process, the 10 strategies for automation and production systems, and the automation migration strategy. All right, so what are those 10 strategies? Well, one is specialization of operations. In other words, we don't want to have too much stuff happening at one place when we could spread it out and make it faster as a result. In other words, when we make a car, we don't get two guys and say, there's all the parts in a pile over there, make a car. No, we split it up into subtasks so that, the first thing that happens is maybe two guys put the frame on the line, right? And then it goes, and then in the next location, it gets the engine put in. In the next location, the transmission and drivetrain is put in, and so on down the line. We combined operations anytime we can that it is going to, that it makes sense. I mean, sometimes you could do in one operation what was being done in 5 or 6 before by a simple redesign of either the product or the process. Have simultaneous operations. Pardon me, this is just so loud. Of course, as soon as I make a move towards the door, they shut up.
Yep.
Simultaneous operations, what can we do in parallel at the same time? One guy or one machine is working on one end of the product. Can another guy or another machine be working on the other end at the same time? Or making something that's going to go on it in another workstation right by it. We want to make sure our operations are integrated. This goes back to some of the principles we discussed in Lean, where we don't make 10,000 in a barrel and then move that barrel. We aim for one piece flow so that we can immediately interrupt if we have a problem. Was that a hand being held up or just a casual wave of the hand?
No, it's casual wave.
Okay, carry on. We're more and more looking for flexibility in how we put things, how we build our products. Flexibility as far as mixed model type production, where today instead of making 5 of product A, 3 of product B, 2 of product C, we make 4 of product A, 5 Bs, and 1 C. But also flexibility on what are the product features. Can those be changed on the fly? Improving our material handling and storage. When I was a not very experienced industrial engineer, I went to the boss with a plan and I said, if 2 guys work together on this, they can do it super easy. He said, great, now go design a way that 1 guy can do it. But the thing is, as we look at the workforce that we have to deal with, we have to think in terms of making jobs as much as possible so that anyone can do them. right? You might have a big burly guy doing a certain process on the day shift, and then on the evening shift, you have some 50-year-old lady who's not very strong come in. A process that both of them can do without strain is what we're aiming for. Online inspection, one of the problems of a more traditional mass production is that inspection was done after the product was finished, and then they'd say, oh, well, this product has this problem, this problem, this problem, and it would have to go back and get reworked. If we catch the problem immediately after it happens, obviously, we spend less time fixing the problems. Process control and optimization, obviously, we're going to be doing that as much as possible. Plant operations control, again, that goes back to integration of operations. More and more, we want an understanding and an understanding back and forth of what the operations are doing and how they relate to the operation before and the operation after. And computer integrated manufacturing. Obviously, it's something we want. So, our automation mitigation strategy means that when we're first making a new product, we're going to make it mostly by manual production. There may be some parts where we have to go ahead and automate immediately, but we're going to mostly build the product manually as we work the kinks out of the process, right? Even though we assume we have great engineers working the working on the product and how we should do our processes and so on, we know that something is always going to be overlooked. So often in this phase we're talking, you have single station workstations working semi-independently. It has the advantage it's very quick to set up, and hopefully all our tooling is very low cost. When we move to phase 2, that's when we automate the production, and each individual workstation, we look at it whether we should automate it. Now we have to remember, we don't just automate so that we have an automated factory. It has to be a financial decision. We have to show that the automatic machine will make us more money than having a manual production. I would say the economics are what are going to justify the automation. We're not necessarily going to make more money because we automate even as demand goes up. And then phase 3, automated integrated production. So you're talking about, we have multi-station kind of work cells. They have serial operations, automated transfer of work units between stations. the CNC machine at the Fab Lab. Have y'all been using that a lot?
Shane has. I haven't really used it yet, so.
All right, well, one of the features of a machine like that is that you can program it so that it changes its own tools, it's following its own tool path, right? All you have to do is set the piece in and start the program. And there are even machines where you don't have to set the piece, the machine can set the piece itself and put it out to go to the next station. All right, so this is showing the three phases as they envision them. Up here we have the manual handling, manual workstations, right? And they're assuming the product demand is low and production itself is not going to be very high. When they go to one station cell automated production, right? They're assuming product demand is a bit higher. And then the automated integrated production, they're assuming everything is connected together and the machines can mostly run and make the product without human interference. Only occasionally because something jams or a machine runs out of parts or something of this nature. All right, so so in this book we're going to talk about manufacturing, automation and control technologies, material handling and identification technologies, manufacturing systems, quality control systems, and manufacturing support systems. Okay, so having said that, we plunge into where we're starting to talk what are the different levels that we're dealing with in dealing with this situation. So we have our factory level where it's more or less just the things that would have to happen on the factory floor to make products.
Sorry. I locked in my key on Dr. Itisham's classroom. Can I borrow your key?
Well, I don't know, you might lock my key in there and then where will we be?
Sorry. Are you in Zoom right now?
No, I am not, because your damn email won't let me log on to my email.
Oh. No, you can log out that email.
It won't let me.
It won't?
No.
Okay, did you call IT?
No, I didn't call
Okay,
IT,
I'm
we have to
gonna
have class here.
I'm gonna call IT.
Okay, good on you.
Okay. Thank you.
Okay, so the factory level, that's just, people are working and they're making products. When we start thinking about the whole business, that's when we get up to the enterprise level and our manufacturing support systems. The sales and marketing, the design guys, the prototype shop, the manufacturing engineers that put together the processes. So there. Whew.
So that
need to look at your book, and I'm trying to think of how to do it without touching it, because I can already see you're somewhat paranoid.
So you need to look at the book without without touching it. It seems to be going along with what you have.
Right. Well, usually they don't do, all right, go to the very end of chapter 1 so we can look at the questions.
So these are the questions. Looks the same.
Okay, great. All
Okay.
right, so I can go ahead and
Assign
I'll just assign some problems based on what I've got here.
And then it'll be due on Monday?
No, it'll be due a week from
Okay,
today.
so on Wednesday, okay.
Yeah, always you get a week unless we get into a tight spot.
Okay. I'm so paranoid about everything.
I don't blame you a bit. I'm actually a very paranoid person myself. Um, I am actually not as paranoid, though, about COVID as I could be. All right, so let's do problems 1.3.
What is the course code for this class? IE?
484. Let's do 1.5. 10. One point 11 and 1.13, and today's the 12th, so these would be due on 8/19/2020.
Harry, it is on, sorry, you're done? It is on this computer, right?
Yes.
Oh, sorry. Did I have my login? Oh, I tried to log it out, but I don't know I can. I can't use Zoom because we're down email. Oh, Harry.
Easy for you to laugh.
You're right. Even though when you have a meeting, whenever you give comments, Jose Vanguardia is kicking up. And I said, what the heck? I didn't say anything. And later I realized you're sitting on the desktop that I used last summer. So it is still in there.
Okay, great. And print this out so I can put it on Moodle. And now we'll let Jose demonstrate his tremendous ability.
Of logging up.
Yeah, I have a class, Harry, by 3:05. Oh, it's almost. Harry, thank you. I'll be back. I still could not get
Yeah,
out.
you're really helping me here.
All right, on the that wonderful note, I'm out.
All right, have fun.
You
I'll
too.
see you next,
Monday.
yeah, it comes back to me Monday.
Are you Raga? Is this characteristic materials?
I'm sorry, I can't even hear you.
Is this like characteristics of materials?
No, it's not.
Or, you know if the instructor is here for that class?
I have not seen him.
Yeah. I was trying to. Is there class study here? It's you.
Well, there is